Hi everyone, this is Mr. Hall and this is my third video on solution calculation. So up to this point I've gone through in my other videos about the equation triangle between concentration, moles and volume. Here I'm going to be talking about how you convert between units, which can get quite complicated and you just need to be very alert as to how to do these kind of things. So the objectives for today are as follows. I'll be helping you to calculate the concentration of a solution in grams per decimeter cubed, which may be new to a lot of you. To also convert concentration from grams to moles per decimeter cubed, and then from moles per decimeter cubed to grams. We'll also calculate the number of moles or the volume of a solution with a concentration in this, and also to calculate the mass of a solute in a solution. So there's quite a lot of different skills that I'll be helping with today. So let's get started. So first of all, let's say you've got two different solutions like this, okay? Now, the solution on the left, it contains 1 mole of sodium hydroxide. And the container on the right, it contains 1 gram of sodium hydroxide, and both containers are 1 decimeter cubed. Now, the first thing to think about is how are these solutions similar? Well, the first thing that we have to know is that they both have the same volume, all right? And that's really important, and that's quite useful for later, okay? They also both contain sodium hydroxide. Both contain NaOH. Now, the difference between them is that they have different amounts of solute. Okay? So although one of them has 1 mole of sodium hydroxide, the other one has 1 gram, and you have to be quite good at converting between the two. Now, in terms of the concentration of the two solutions, this one over here, you've got 1 mole, and it's in 1 decimeter cubed, so it's simply 1 mole per decimeter cubed. But this one's really complicated, right? Because it's got 1 gram. So what we'd have to do here is we'd have to work, if we want to get the unit in moles per decimeter cubed, we have to work out how many moles are in a gram. Now for that we need MR. So the MR for sodium hydroxide is going to be 23 plus 16 plus 1, which is 23, 33, 34, 40. Okay? So to work out the concentration in this container, it's going to be concentration is moles divided by volume, but we need the moles in 1 gram. So the moles is 1 divided by 40, which I think is 0.025 perhaps. 1 over 40. Yeah, it's 0.025. Okay, therefore that will equal 0.025 divided by 1, which equals 0.025 moles per decimeter cubed. Now you can see that that has a much smaller concentration than the box on the left. But there's another way in which we can represent this concentration. We don't have to show it a moles per decimeter cubed. We could just say that it's 1 gram in 1 decimeter cubed, which equals 1 gram per decimeter cubed. And that's another way, in some ways it's an easier way of representing concentration. So this takes us to our initial triangle, which was this, which I showed in my previous video, but now the top M has changed a bit because now it's just mass and the unit is obviously in grams. Concentration remains as it is, but the unit is now grams per decimeter cubed, and my volume is the same, it's still in decimeter cubed, but you might need to convert between centimeter and decimeter cubed by either multiplying or dividing by 1,000. So let's do some practice for the basic bit. So let's say we've got a solution where you've got 0.28 grams of potassium iodide is used to make 0.45 decimeter cubed of solution. What's the concentration? So first thing I do is I work out my equation triangle. I've got mass at the top, concentration here, and volume there. So I'm trying to work out concentration, so it's mole mass divided by volume. So concentration equals mass divided by volume. My mass is 0.28, that's from my question. And my volume is 0.45. There's no need for converting because it's already in decimeter cubed. So 0.28 divided by 0.45, and that gives me 0.62. Now that's recurring, but because it's just to 2 significant figures, I'll keep it as 62, and the unit there is grams per decimeter cubed. Let's try another problem. 0.46 grams of sodium hydroxide is used to make 220 centimeter cubed of solution. What is the concentration? So the first thing I have to do here is do a conversion. I've got 220 centimeter cubed. I want that in decimeter cubed, so I have to divide by 1,000, which gives me 0.220 decimeter cubed. I then have to work out the equation for concentration. It's the same as the previous question. So you've got mass, concentration, volume here. So my concentration equals mass divided by volume. So concentration equals mass divided by volume. My mass is 0.46 from the question, which I underlined. And my volume is 0.220. Note I'm using the correct unit. And 0.46 divided by 0.22 gives me 2.1 grams per decimeter cubed. Again, I've abbreviated that to two significant figures because that's the lowest one I've been given, because these are both two significant figures. Okay, let's try another problem. Now this one's a lot more complicated. So it says 0.15 moles of sodium chloride is used to make 455 centimeter cubed of solution. What is the concentration? There's a lot going on here. The first thing I'm going to do is I'm going to convert my volume. So I've got 455 centimeter cubed. I'm going to divide by 1,000, which gives me 0.455 decimeter cubed. Now the tough bit is the moles. Okay, and I've got sodium chloride, which is NaCl. Now first off, I need the MR of NaCl. Now that will be the AR of sodium, which is 23. I add that the AR of chlorine, which is 35. You could round, you could say 35.5. I'm just saying 35, and that would equal, so 23 to 35 is 58, I think. Okay, then I have to work out the mass because I want it in grams per decimeter cubed. So the mass, now if you remember this from previous learning, is going to be, the mass is moles, or rather, sorry, I'm going too fast here. Moles equals mass divided by mR. Okay, now that's the initial equation that you've got. Now we don't want to work out moles, we want to work out mass. So to do that properly, you want mass equals moles multiplied by mR. Now my moles is 0.15, my mR is 58. So if you put that in the calculator, so 0.15 multiplied by 58, and that gives me 8.7 grams. Okay, now I can work out my concentration. Now I'm not going to go through the whole thing like before because it's pretty much the same as the other problems, but it's going to be concentration is mass divided by volume. My mass is 8.7 grams and my volume is 0.455. Therefore my final answer is going to be 8.7 over 0.455, and that gives me, rounded to two significant figures, 19 grams per decimeter cubed. Now you can see that this process is really long because when you've got moles and you try and work at grams per decimeter cubed, or you're going the other way, it can be a real nightmare. So there's a simpler way of doing it. So we know that we've got moles per decimeter cubed on one side and grams per decimeter cubed on the other. Now the easiest way of actually converting those two would be to multiply by mR. So if you're going from moles to grams, you multiply by mR. And if you're going from grams to moles, you just have to divide by the mR. It's a very, very easy way of remembering, okay? So what I'll show you is a couple of examples of how to use this and make your calculation just a little bit smoother, okay? So if you have a solution of sodium hydroxide with a concentration of 0.25 moles per decimeter cubed, how can you convert that to grams per decimeter cubed? So the key thing to remember here is that you, in order to go from moles to grams per decimeter cubed, grams per decimeter cubed, and then moles per decimeter cubed, like so. Just remember, if you remember the last thing, it's multiply by mR. So this you would multiply by mR, this you would divide by mR. So let's work out the mR. So for sodium hydroxide, mR, it would be 23 plus 16 plus 1. So this is the AR of hydrogen, the AR of oxygen, and the AR of sodium. So 23, 33, 39, so that would be 40. Okay? Then you can do your conversion. So if I'm trying to work out the concentration in, what have I got? Grams per decimeter cubed, I would multiply the concentration in moles per decimeter cubed by the MR. So it would be 0.25, which is over here, and I multiply that by the MR, which is 40, and that would give me, I think, 10. So it would be 10 grams per decimeter cubed. Okay, so that's how you would do it. So it's simply just multiplying that concentration by the MR. Always show you're working though. Like, don't take a shortcut here. Doing that really pays off. Okay, really, really important. Now let's try go the other way. So if you have a solution of HCl with a concentration of 32.5 grams per decimeter cubed, how can you convert that to moles per decimeter cubed? Again, the first thing I need is my MR. So my MR for HCl is going to be 1 plus 35, and again I've abbreviated that. That's the AR for chlorine, this is the AR for hydrogen, and that equals 36. Now I need to work out my concentration in moles per decimeter cubed, and it will be the concentration in grams per decimeter cubed divided by the MR. So you have to do the opposite if you remember from what I showed you before. So the concentration that I have is 32.5. Now my MR, I just calculated it here, is 36. So it's 32.5 divided by, and that gives me, sorry, that's my bell, and that gives me a number of 0.90. Okay? And that again is to two significant figures because of the two significant figures of my data there. Okay? And the unit for that would be moles per decimeter cubed. And that's it. So I hope that's been useful. I hope it's been thorough enough to help you with those calculations. And best of luck with the calculations that you have for your future tasks.